G'day. This is my IoT data management project, and I'll show the UI while I talk through sort of the introduction. So I had three big drivers for this. First, I wanted to get off Google Cloud services, the bit overkill for my previous IoT projects like ourBoatMonitor. Is just too much trouble to keep an eye on it, and for the amount I was using that, so I decided to bring it in-house. And two, I wanted to have all my data and services on my home network, but my big worry with doing something like that is getting hacked or opening a port on my access to the internet. So you'll see what I came up with to protect my home network and really expose as little as possible. And the third part, and you can kind of see the generic client I put together, is to have a generic client that I can use to look at my IoT data. It took a while to get this working, probably a couple of months from start to finish, but I don't want to go into a lot of detail about it. All the detail is on GitHub, and I'll put the links for GitHub and access to the code and things like that if someone wants to do this themselves. So I'll just talk through some kind of the main design decisions I made, and any gotchas in the code that may be interesting that I haven't gone through before. So with that, let's get going. By the way, what you see on the screen at the moment is me pulling the data that I downloaded from my IoT client, bringing it into Excel so I can use it in there as well. The architecture. So this sort of shows my home network inside this black box here, and then the internet out here. And the way I put this together was I wanted to expose the minimum things to the internet from my home network. So data comes in from the internet into my cable modem, gets forwarded to a Raspberry Pi Pico. Now I'm using like a strange port number to do this, just to make it a little harder to find on the internet. And then I'm using a Raspberry Pi Pico just because it's a very simple device. There's no real operating system running on there, so what you see is kind of what you get. And again, to make sure I was as safe as possible, I didn't really want anything other than what I know is running on that Raspberry Pi Pico to make it a little less hackable. So this device I called iotCache, and its purpose is to receive IoT data, save it away, and basically does store and forward. So when this iotLoader down here requests any new data, it gets forwarded through to this part of the architecture. So this one's called iotCache, running on a Raspberry Pi Pico. So the next part down here in this yellow is my main server. I'm using a Raspberry Pi 5 with SSD, and that's because I'm running a database. I really need an SSD to manage the disk. And on this Raspberry Pi 5 I have two main programs, iotLoader and IoT web services. iotLoader, like I say, periodically goes out to the iotCache, gets any new data, pulls it down and loads it into this Postgresql database, which is set up like a time series database. We'll have a look at the schema for that and what sort of things it holds. This Postgresql database is then interfaced via IoT web services, which is a fastAPI type web service application, and that web services provide data, access to the data that I need on the PostgreSQL. Then the final part of this is I wrote an Angular UI. I called it IoT UI, and this is kind of the pattern I've followed for other projects I've worked on, is to make a fairly simple Angular user interface to access web services that I've exposed. And that's the client you saw at the introduction to this video, where I can do things like see the latest status for the devices I'm collecting IoT data for, do charts on that IoT data, and look at the data in detail, or even download the data. And because I'm using Angular UI front end to these web services, you can just use a normal browser to access that client and see the IoT data, which is, again, the point of this is to get it on my home network and then just have a generic IoT client that I can use to access all the different types of IoT data I may have. A couple more notes here. I'll show you this IoT sensor at the end. So this is a little application or a little RPI Pico project I made to collect climate data and send it up to the IoT cache. This was kind of the purpose of why I started on this, is I wanted to start to collect more climate data. So I'll show you this IoT sensor and just show you how that works. And then the other thing I wanted to do was change my my boat, so it collects data about the boat status all the time and sends it using NB using cellular data up to a service called Hologram, and that was sending it over to Google Cloud Services. So I'll just show you what I did in Hologram to change those services around, so it now routes it to my IoT cache as well, and that data is now available on my IoT home services. So let's get started. First I'll have a look at this IoT cache and see how that's put together. So let's have a look at how IoT cache works. So remember, it runs on a Raspberry Pi Pico inside my home network. So it's just listening on one specific TCP port for these web services here. So it either looks for a post with the write route, a get with the write route, a get with the read route, and these are just some supporting services here. So for example, a sensor out on the internet does a /write, in this case does a get with the query data of IoT data equals, and then this JSON string here. So it requires device ID, app ID to be entered along with a username that matches what IoT cache has been set up to recognize. Any other users it'll just ignore. And then the actual IoT data, and this is just JSON data and can be different for different sensors. So it just takes, in this case, for a climate sensor, the Celsius reading, the air pressure, and the humidity. And as well, I'm setting up a sensor timestamp in this case. So that goes to the IoT cache, and what it does when it receives it, it just writes it out to a file in the /data folder on the IoT cache, and that's kind of the store part of the store and forward mechanism as it builds up these files. And the second part of it is iotLoader. Remember, that's running on my Raspberry Pi server. It does a get with a read, and the read just tells IoT cache, get the next available file that's out in data, if there's one out there. It'll retrieve it, send it back to the iotLoader to be loaded into the Postgresql database, and delete that file once it's been read. So this way you can sort of collect multiple files if the iotLoader is not running for a while, and the iotLoader will just request them when it wants them. Note all the stuff's out in, all the code's out in the GitHub repository. That's the URL there. I'll put it down in the description as well. So I'm using VS Code for my coding environment, and I'm also using add-in. So in extensions, you'll see I'm using MP Remote, which is a way of managing the remote micropython environment on the Pi Pico. Let's quick look at the files. So there's main file that gets fired up at the beginning, and all it really does is fire up the app.py code, and we'll have a look at that in a second. I'm using Microdot as my web services library, and I've looked at that in other videos, so I won't go over here, but it's very much like Python Flask if you're used to that. And the other one I want to have a look at is just the settings file, and just note that I don't include it in the stuff getting uploaded to GitHub, just because it's got secret stuff in there, like my password for my Wi-Fi and the port and the users that are valid for this. So let's have a look at the settings JSON file. So this is my settings JSON file. So it has the SSID of my Wi-Fi, my password for that Wi-Fi connection, the location of my NTP server, and I just have it running on my home server to get the time. It has the port number that the iotCache listens on, and then the valid users for iotCache. Now, a really quick walk through of the AppPy code. I won't spend too much time on this, but first it just connects to the network. You see it doing here. I'm requesting a hard-coded IP address for this because I'm using port forwarding, so it's easier to port forward to a known address. And then it gets the NTP time off the NTP host. If it fails to get the NTP time, it just resets and starts again. After that, we go into the microdot code. There's a series of decorators, so just like in Flask, decorators for posts and gets, and the route after that. So the right route for post and get, the read route code, and then a couple of helper functions where I can just get the status of what files are out in the data directory. So that's about it. About the only real interesting piece of code other than that is this routine to write IoT data. So again, this writes the IoT data to the data directory, does some validation, so checks that app ID, device ID, and user are present, that the user is one of the users that I specified in the setup JSON file, puts another timestamp on it. This time it's the timestamp of the iotCache when it received it. Makes that unique, so just in case two timestamps come within the same second, it just puts a random number on the end of it, just to make sure that no two timestamps are exactly the same, and then writes it out to the data directory. Let's have a look at the server side of things. So again, this is running on a Raspberry Pi with a SSD as the storage medium. Basically because I'm running PostgresQL database on here, and there's a lot of I/O going on. So the way I thought I'd have a look at this is first have a look at the setup.sh file. This is in the IoT repository, and this is how you set up the Raspberry Pi. So I've got most of the instructions in here. Shows you how to set up Git, set up a username and password, clone the Git repository for IoT down to the Raspberry Pi, and after that you should be good to go. You could try running the script or just run the commands one by one. Basically it's doing an apt upgrade just to make sure the latest stuff's on the Raspberry Pi. Then it does an update to make sure Python 3 and Python 3 pip is installed. Then I do the install of the PostgresQL. This is the commands for that. This takes you through how to create the user for the PostgresQL database and how it all gets set up. And I'll have a look at the database in a sec, see what structure is to that. So once all the database is set up, I also install PSI-CopG, which is a Python client for the PostgresQL database. And after this, we set up the iotLoader service. So once that was coded, I set it up as a service to run in the background. So again, it's set up at the moment every 30 seconds, go out, pull data down from the iotCache and put it in the database. So these are the commands you really need for that, and then after it's installed you can just run it as using the systemctrl command. Also on the Raspberry Pi I install fastAPI, so this is the again Flask type web service interface to Python services. I installed Unicorn as the web service, seems to work well with fastAPI. And once that's all set up, then I also install the iotWS, which is the web services. Finally, down here you see I install SMB client. That's because I do backups nightly of the SQL database and send those over to another machine just to make sure I've got a good backup of the latest data. Now let's look at the actual database, so Postgresql database. I'm actually using DBeaver as my client to access that database and do most of the DDL type stuff and have a look what's in the tables and things. So using that, first thing I have a look at here is show you the schema. This is the diagram of the schema. So I've got 4 tables that make up this database. Measurement table is where all the IoT data goes. So it has a timestamp as universal metric time. A JSON field that holds the actual data because different IoT measurements from different for different applications contain different data. One could be client, another one could be bilge data, such as on my boat. So a lot of different types of IoT data. So I use this JSON field type to hold the data. Also holds a reference to an application ID, which tells you what sort of data is on that record, and device ID, which tells you where the data came from. So that leads us into the other 2 tables. So got application, which has a name and a description for an application, has an ID, which everything keys off, and then a list of fields that are typically found on that type of application. So it's really just an array of strings, and for climate it may be Celsius, air pressure and humidity. The other big table is device, so that really just a full name and a description for a particular device, otherwise we reference it by device ID. And this final table here, application device, first I found I needed a way of tying together particular applications that are running on a device, or a particular device, what applications they run. So that holds that information, but as well it holds the latest data for that combination of application and device. So rather than having to search through measurements to find the last record for that application and device, I can just go to this application device and it'll just always have the latest data there. And you'll see later on in the user interface I have a status view on devices, and it can show me all the latest data. So again, quicker than digging through the measurements for that. Let's have a look at some of the data. So first let's have a look at application, and here's typically what I've got in application at the moment. So I've got 4 applications defined, one for climate information, one for location, which is basically longitude and latitude, and one for vehicle information. So for the vehicle where it's a boat, it's the battery and various bilge measurements in this case. And you can see here where I'm thinking I'm also going to add some Pico green data in here. So I haven't done that yet, but I need to make a loader to get data from my electricity department, and they call it green button data, and load that in, so I sort of get hourly usage of my house electricity as well, and I want to tie that into the climate data later on. So that's a future. So another piece of data, another table is the device table, and here's the 3 devices that I've got set up at the moment: boat, bedroom and front room. And then the main table is this measurement one, holds lots of measurements for in this case you see it's mostly climate data, because I hadn't started the boat data until a few weeks in. And you can see here where the data field holds the actual measurements for climate at the moment. And finally, let's have a look at application device So here you see a reference to an application and a device. There's only one for each of those, so those form the primary key, those two keys there. And then a date and the latest data for that application to device. Okay, let's have a look at iotLoader code. So this is it. There's not too much to it. It uses a DB-IOT library that I wrote, and this is the one that provides interface, Python interface to the PostgresqL database. It also uses settings, much like we saw in iotCache. So again, my secret settings are in settings.json, and the settings library provides access to those settings. So we import settings, create an instance of settings. Just note I put some SQL at the front here, just so I could remember it and have a place to find some SQL for doing things on the PostgresSQL database. Okay, let's look at the code. So remember, this usually runs under daemon and systemctrl. So while true, it'll do this loop. I put it in a big try catch loop, so just in case something really goes wrong, it doesn't kill it. It actually will keep going. So first I get the settings I want. So that's the user to access the iotCache, the port that the iotCache is on. Load seconds is the number of seconds between each iteration of checking to see what's out on iotCache. And host is the host name for the iotCache. So it puts together a URL and sends a read command. Then goes through, reads the data that was returned. Make sure there's a application ID, or sets the application ID and the device ID. Also sets the timestamp, and there's varying levels of good timestamps. So the best timestamp's always going to come from the actual sensor. So if the sensor provides a timestamp, then it uses sensor timestamp. Otherwise, the IoT timestamp is the one that was provided by the iotCache. If neither of those are present, then it'll look for received data. So this is something that Hologram IO provides. So if it sees a received timestamp out there, it uses that as the timestamp, best timestamp available. Otherwise, it just uses the current time. So varying levels of good timestamps, but tries to get the closest to when the actual data was measured. And then it calls this add measurement function, which is down the DB-IOT. And add measurement, let's see if we can find it. So there's add measurements. So that's where the code is. I won't go through each of the lines. I put fairly decent comments on there, but goes through and either does an update or an insert. Does an insert to the measurements table, but for the application device table, which is always gets updated, except for the first time it gets created, it either does an add if it doesn't exist for that particular combination of application and device, or else does an insert. And then after all that's done, does a commit for those two transactions usually. Just note on the iotLoader service, this is the service file that runs the iotLoader once it's set up, or once the Python code's available. Okay, let's have a look at the actual code that provides the IoT web services. So remember, I've got a Angular client that talks to the web services. That's the way I get to see all my IoT data. So this is the file that contains most of the code for the web services, IoT web services. We saw in the bash script that I'm using fastAPI. So this is the imports for the fastAPI components I'm using. I'm using DB-IOT again, so again that's the interface between Python and my Postgres database. And also I import asynchro because fastAPI runs in asynchronous mode. We set up fastAPI, and then we've got the decorators for all the web services. So these are the routes that the web services provide. So things like getting the measurements, getting a list of devices, getting a specific devices, getting a list of applications, getting specific applications. And you see most of these are fairly simple. It just does a call on the DB-IOT class that I put together, and then calls the relevant service in there, and that just returns the results. So DB-IOT is doing most of the requests to the database and formatting any results that come in. You also note at the beginning of this, I'm using uvicorn as the web server for fastAPI. So if you're testing, this is how you fire up uvicorn to run this iotWS file. And another note on why I'm using fastAPI, it provides documentation about the web services you put together. So if you look at something like if you look at a browser and go to the docs route, then it tells you all sorts of information about the web services you just created. And you can even test those web services out. So in this example, I'm just calling the service that gets a list of the devices, and then you see it being returned as JSON. So again, this is what's used in the Angular client. The only other thing to look at here is how I run this as a service. So in this case, we've got the iotWS service, same sort of thing as the iotLoader service, as a service file for systemctrl to use. This one fires up after the network's started, after a boot. Has information about the user and the group that I'm running this under, and in this case, to start this iotWS app, it actually has to fire up uvicorn as well. So you see it's firing up uvicorn there in the exec start. So all the code for the IoT server side of things is in this GitHub repository. I also put the link down in the description below. Let's have a look at the Angular client. This is running on my iPad mini. So there's a status tab. There's a charting tab where you can select what you want to chart. And there's also a data tab where you can see the detail data for a device. I put all the code for this up in GitHub. The link for that's down in the description as well. This isn't going to be a tutorial, otherwise this would take about 10 videos to do, but I'll just show you where things are and any interesting things I did in this particular client. So this is my Angular project open in VS Code. You can see the main components here, so let's have a look at what those components are on the interface and some of the things they do. Just to note, the top level component is this app component, and that's the thing that holds the tab control with the status, the chart, and the data tabs on it, which open up these components, the status, chart, and the data components. So if we have a look at the user interface, we can sort of see where these components are used. So this is the status tab shown in the user interface. So status tab, and uses the status component to deliver that. And then on the status component, as well as having one of these drop downs for selecting a device, it has this component called device status. We'll see that in the project as well. So in this case, there's three different applications running on this device. My boat device, there's a location application, climate application, and vehicle application. So when it pulls back the status for the boat, it gets these three records for each application, and uses device status 3 times to render the details about each of the applications. So we see the status component here that we just looked at, and device status component here that we just looked at. Next one we'll have a look at is the charting component. So this is the charting component. So here's the charting component from the user point of view. So I click on the chart tab, brings up the chart component, and has the selector component I wrote to make selection of the parameters from the IoT database, fairly straightforward. So I can select the application. In this case, I'm selecting climate. I can select which device. So in this case, I'm charting from the front room device. I can select the measurement that I want. So for climate, there's 3 measurements. So I need to select which measurement I want to chart. So in this case, I'm charting Celsius. Start from time, so it's kind of the duration. So it always goes up to now. So 6 hours ago in this particular chart. Then I can also have a summarizing option. So say I get a month's worth of data. I don't want to see every single data point, so I can summarize by hour or day or whatever selection I want. And the final thing on the chart component is I use NGX charts or swim lane charts to do the actual charting. So again, we see these components in the project here, the chart component, which has the selector and the display chart, and the actual chart, which uses NGX charts. And I'm also using the selector component here, which was showing all those drop downs for selecting the various parts of what I want to select on. I made that a component because I'm also using that in the data view as well. So let's have a look at the data view. Okay, this is the data tab. So we see selected the data tab. Again, that's using the data component to render the data tab. I'm using the selector again. This selector is parameter driven, so for showing data I don't need to check the field or select the field because it shows all the field for that particular combination of application and device. So I've got an option when I render the selector component to show fields or not to show fields. So that's used on the data component as well. And then when I've selected what I want to see, what data I want to select, it uses mat table or material table to actually render the data that's brought back for that selection. This also has the option to download data, so I'll download it as a JSON file that I can use in something like Excel, and I think I showed that at the beginning of this video too, how I can download data to Excel, which has a lot more flexibility. So if this client doesn't provide what I really want, sometimes I want to compare different series of data. I don't really provide that option in here, so I can download the data for multiple series and then combine them in Excel and chart there to get more complicated charts or do more complicated analysis. And again, in the actual Angular code, I see there's the data component, which is showing the selector again. Here you see I'm passing the request to not show the fields. So this is how the app selector shows different views, whether it shows the fields drop down or not. And again, I'm using the selector component, and you'll see down here I'm using mat table to display the results, and it's kind of nice. The mat table turned out to be a fairly easy way to format and show results of kind of a simple table results being brought back. Things in the code that were a bit tricky for me anyway. It took me a while to work out how to do. So one thing is on the chart. It's a time series chart, so it uses time data on the x-axis, and I found it really hard to get a decent format for the time on the bottom. So I'm using this option here in NGX charts called x-axis tick formatting. It didn't work that well inside the actual code. It took me a while. I couldn't see my globals for some reason. It seemed to be a bit finicky. So I ended up doing this by selecting a different routine for doing the formatting of the x-axis depending on whether I'm showing hourly data, daily data, or just all data. And you can see here's how I select each of the different formats, and down in the TypeScript file you can see the 3 formats where it's formatting the date displayed in different ways and different summaries and information. So I'm kind of interested in the day when I'm looking at days, and interested in the month when I'm looking at the month. I like to have those called out. So there's one tricky bit. The other tricky bit was in the data component. So I download the results here, and let's have a look. In the get data, remember it's JSON when it comes down, so I have to sort of blow this out into columns, and in the HTML I'm using @4, so this is Angular 17, so using the @4 decorator inside the HTML to build up the list of columns that I'm going to show. And I get that list of columns down here. Where it's using object.keys on the JSON that's coming back to get the list of keys for the in the object, and that goes into my columns structure here, which is really just a array of strings, and that's what's used by the for loop here to define the columns based on the names of that particular set of data. And remember, sets of data can have different values coming back depending on whether it's climate data, location data, vehicle data. Can be almost any sort of data. So I wanted to make IoT database very flexible. That's why I'm using that JSON field, but I have to interrogate what data is coming back to work out what columns are going to be shown in the data. The other thing that's interesting, and I use this down in my some of my other projects, is just to do the download results. You see it here, so I click on a button and this puts together a file that can be downloaded with the contents of whatever I send it. So finally I wanted to have a look at these two sensors. The first is what I call the IoT sensor, which at the moment is collecting climate data and sending it up to the iotCache. And the other one I want to look at is existing sensor I had under ourBoatMonitor, which uses NB-IOT over cellular to send data up to hologram, and I rerouted that so it goes to the iotCache as well. So let's have a look at those. Let's have a look at IoT sensor. You can see a picture of my IoT sensor out here. So it's basically a RPI Pico in a little 3D printed case, and I got a BME 280 climate sensor sitting off that. I want to first go through the code structure, then we'll have a look at the actual code, not in any real detail. And I remember the code for this is in GitHub. It has its own repository called IOT Sensor. I'll put the link in the description as before. So let's look at the code. So first it starts up app.py, and its job is to set up the network. So it connects to the network, gets settings. So again, it has a settings file with some secret settings in there for things like connecting to the Wi-Fi and things, and then enters a loop, and that loop loops every 5 seconds, and it's got two tasks every 5 seconds. So first it calls on sensor.py. In this case I'm getting climate data, but sensor.py could be set up to get other sensor data as well, so I kind of separated from the rest of the code. So if you didn't want to pick up climate data, wanted to collect other things, say light or something like that, you could put that into your own version of a sensor.py. So it gets the data and stores it in a JSON file in the data directory. So again, this is a store and forward sort of thing, because I was concerned if it loses connection to iotCache, say the network goes down or something happens, I still wanted to collect the data and then just later on send it up to iotCache, anything that hadn't been sent. So gets the sensor data on a schedule. So every time it goes through this loop, it may not always get the sensor data. So say it's collecting sensor data every 10 minutes. Then every time it goes through the loop, it just checks to see what the time is, whether it's time to collect that sensor data or not. It'll collect it if it's time to do it. otherwise it'll just drop through and go to WebPy. And this is the thing that sends sensor data up to the IoT cache. So it just looks in the data folder, looks for any sensor data files that are out there to be ready to be sent. If it can connect to iotCache, it'll send it up and then come back around for the next loop in 5 seconds. So if it hasn't connected to iotCache for a while, there may be a lot of sensor data files out there. So this WebPy will, every time it goes through every 5 seconds, send the next sensor data file up, remove it. So this is the way it sends data that may have been collected but hasn't been sent yet, and catches up with sending the data. So let's have a look at the code. So the code for this, so again, this is a micropython project running on a Raspberry Pi Pico, using MP Remote again to connect to the Raspberry Pi Pico and sync the code up, run the code, those sort of things. So like I said, when it first starts up, main gets run. If it's to run automatically, so as soon as you power it up, then it'll do an import of app, and it runs this application. So this is the one that collects things like the settings, does a network connection, and then if it can connect to the network, also gets the NTP time, so it can timestamp the sensor data. If all that works okay, then it drops through and goes into this loop where every 5 seconds it's going to do the things within this loop. And the two main things it's doing, like in the diagram I just showed you, it's going to call on sensor get data. So if it's scheduled to pick up data at that time, it'll drop a data file into the data directory. And then the second part is it'll look out in the data directory. If there's a data file out there, then it will call on the WebPy class, and we'll do a send cache server, whatever the IoT data is it's collected. If that's successful, it's going to remove that data file so it doesn't get sent again. So that's about it. Fairly simple. The nice thing about this, or the thing I think's nice about this, is for the sensor routine here, sensor.py. In this case, with get data, I'm getting climate data, so that's what this particular sensor does. But if I wanted to get it to do something else just within this part of the code, instead of loading climate data or getting climate data and loading it up into IoT data, I'd get whatever other data I may be interested in collecting and putting it into IoT data, and everything's still going to work just like before, but for different types of sensors. Look at how I got ourBoatMonitor working with my IoT system. So I put the link down here to a long playlist of describing how I put together this boat monitor, but basically it's a little microcontroller device sitting on my boat in the lake, and it's picking up information about GPS information about where it is, information about the actual boat, like has the bilge got any water in it, what voltage is the house battery at, those sort of things, as well as climate data. And I was sending that through NB-IOT, which is a cellular protocol, up to hologram IO. So all that stayed the same. So I'm still sending all that data up there. I didn't have to change anything down here. But in hologram IO, the way they allow you to send data to the application is through what they call routes. And I had a route set up to go to Google Cloud Services. That's where I was processing the IoT data from my boat. And now I've got this IoT system. I changed the routes in hologram to send it to iotCache. And I actually broke the data down before. I was just sending one lump of data up to the Google Cloud. Now I break it down into 3 applications that the boat's basically tracking. So climate data, location data, which is longitude and latitude, and vehicle information, which in this case is boat type information. So let's have a look at see how I changed the routes in hologram. Okay, so let's see how we set up our routes in hologram. So I've gone into my routes view in hologram. So I've already set up my devices, so the device is coming from the boat. And when I look at my data routes at the moment, I've got 3 routes set up, one for boat climate, one for boat location, one for boat status. So let's just look at the boat climate route, what that looks like. So if we look down here, we can see what activity's been going on. So this is what the boat typically sends up. So this information here, which doesn't tie into the names that I gave the applications in my IoT application. So I needed to break this data up into 3 separate transactions to send to iotCache, and also rename some of the fields for iotCache to match the application, what the applications expect for field names. So let's have a look. Yeah, I'll just close this up and look at the boat climate configuration. So first thing in a route is it ties into a particular device. So the trigger for this route is when this device, which is on my boat, sends data. And then I've configured an advanced webhook builder. So there's different types of routes you can build. I'm using this because it's kind of worked best for what I was trying to do. So I've got advanced webhook builder, build your own, and first you put in the destination URL. So this is the location of my IoT cache, and then I put in what the payload data will be. So things like app ID, device ID. For climate data, I know what the app ID should be, and I know what my device is, so I can just hard code those. Put in the user, that is one of the valid users, and then I pick up the humidity data. So it's called data humidity, coming from the boat, so it maps to humidity, same for Celsius and things. Things like pressure is different from the name I gave the field in the application, so it's HPA. So there's one example of mapping. The other thing I send through is received, which is the timestamp that hologram received the transaction. So remember, up in iotCache, it makes decisions about what timestamp to put on a piece of data, but depending what's available. So for this hologram data, the best timestamp is when hologram actually receives it. So that's the received field, and it sends it as a post up to my application. So that's about it for my IoT system. So now I've got all my IoT data in-house and got a nice client that I can view a lot of the IoT data. If I want to do anything more complicated, I can either go straight to the database and do a tricky SQL queries and get a view over multiple series and devices and applications, or pull the data down to Excel with my download function. Hope this is of use to someone. I don't know, I went through it pretty fast, but I didn't really want to repeat the detail of doing Angular coding, micropython coding and things, because I've gone over those in a lot of my other videos anyway. But at least you'll be able to find your way around the repository with this, and maybe pick up some ideas that are useful. Thanks for watching.